So this is lesson C, the third lesson for Unit 9, and we're taking care of a couple of odds and ends in this lesson. This first part we've been over a couple times. Here's our quadratic formula. Y equals ax squared plus bx plus c. I should say this is the standard form of a quadratic equation. And if we are trying to find the axis of symmetry for this parabola, there's a very easy way to do it. You can use this formula. You find the b term, you use the opposite. You find the a term, you multiply it by 2. You plug it in here. This will give you the equation of a line that is the axis of symmetry for this parabola. Something for you to think about. How can having the line of symmetry help you find the vertex? Okay, new topic. The solution of a quadratic equation is the same thing as the roots of a quadratic equation, which is the same thing as the x-intercepts of a quadratic equation. There may be 2 solutions, 1 solution, or no solution. Why is that? Oh, and I'm going to leave you with something else just to think about. Let's work through this once. If I ask you what are the roots of this, we've got an x squared term and a c squared, or sorry, a c term, not a c squared, x squared and a c term. What are the roots of this quadratic equation? Well, solve the equation. You've been doing this since September. Take the square root of each side, because you can do anything to one side as long as you do it to the other. And I'm not sure if this is a new sign for you or not. M equals plus or minus. That's not a 36. Hold on. So like I was saying, M is equal to plus or minus 6. Why is it important to use the plus or minus sign, which is this, the plus on top of the minus? Well, because remember there are 2 things that you can square to get 36. You can either square 6 or you can square negative 6. All right, one more problem I want you to look at. This is actually a fairly practical application of your math. You might use this someday. A ball drops out of the baffles on the ceiling, those are those big gray felt things, and falls to the floor. You could put the relationship of the height and the time that the ball is falling into a quadratic equation, such as this one. The question is, how many seconds does it take the ball to hit the floor? This question is really asking, what are the roots of this parabola? Because we are wondering, when will height equal 0? Height will equal 0 when that parabola crosses the x-axis. How long does that take? Let's solve this problem. Here's your next set of problems to do. Your next lesson is going to be called 9-4 because I'll be mostly following the book for that one. And the only thing that might give you a little bit of challenge here is these first few problems you need to find not only the axis of symmetry but also the vertex. And I asked you to figure out how you're going to do that. If you get really stumped, of course, ask me, or you can always look in your book. Good luck!